Hello, ladies and gentlemen, and everyone out there. Root Beer here, and I'm going to be looking at the 2019 Fermat paper. In fact, I'm going to be finishing up the 2019 Fermat paper with our last question, question number 25. So let's dive in and have a peek at what we've got here. So, question 25. In triangle QRS, this triangle over here, point T is on QS with QRT having the same angle as SRT. Suppose that QT is M and TS is N for some integers M and N with N greater than M, and for which N plus M is a multiple of N minus M. Interesting. That doesn't normally happen. Suppose also that the perimeter of triangle PQRS is P, and the number of possible integer values for P is m squared plus 2m minus 1. That looks very, very similar to m squared plus 2m plus 1, just differs by 2, which happens to be m plus 1 squared. Just an observation. And they're saying this is all enough to figure out an exact value for n minus m. Okay. So there's not a whole lot to go on. M and N are given to us, and they are integers. Now we want the perimeter to be an integer as well, and we also know that we've got equal angles up here. Oh, is this, are we going to use the fact that an angle bisector, the ratio of that it splits the side is the ratio of the corresponding side? That's an interesting thing we could use here. I'm just trying to think, why would they give me the angle by the thing that splits the angles? These two angles are the same. But there's a nice result that says if this side, if you've got a ratio of m to n, then the corresponding sides on either side of the division of the angle bisector here. So it's the same ratio. So this is m times some r for the ratio, and this would then be nr. Okay, so this holds true for the angle bisector here. All right. It's not the most common geometry result. I don't know whether or not we'll need to do something else, like maybe some trigonometry. It is a grade 11 paper. But that's something that immediately jumps to my mind. Now I've got the other two sides, sort of, and they are talking about the perimeter. So I feel pretty good about this result, yet talking about the other two sides in terms of the ratio that the angle bisector splits the other side. Yeah, so now we can describe P, I guess. So P is m plus n for this side, plus mr. I don't know what r is. R doesn't have to be an integer, but it will at least have to be rational. Because I can take out a factor of m plus n times r plus 1. Mn is an integer. P, we're concerned with integer values of P. And then r plus 1 need not be an integer, but it will definitely be rational. Okay, and we've told m plus n is a multiple of n minus m, and we are trying to figure out n minus m. So actually, I suppose I could write it over there. So let's let m plus n be k times, it is n first. Maybe I should get in the habit of writing that. And this k is an integer. So k is an integer, r is just rational. R is definitely rational. But k has to be an integer because n plus m is a multiple of n minus m. Okay, so what all can we do here? Well, I suppose I could rewrite P is k times n minus m times r plus 1. This adds in every variable we've got here. Are there any other immediate observations we can make? Well, n minus m is just n minus m, but if I add n plus m, I'll get two n's. Both of these are multiples of n minus m. So 2n needs to be a multiple of n minus m. And we can probably do the same thing, do n plus m, do n minus m, and take the difference, and you'll get 2m, because the n's will cancel out. So now we'll get k minus 1. Okay, that doesn't necessarily mean m is a multiple of k minus m, because maybe you're, of n minus m, because maybe k is 3 or something like that. But, okay. So we've got that. So right now I'm finding connections between the variables. I think we're gonna have to go back to the information given in the problem and talk about the parameter. So what'd they say? P has a certain number of integer values, right? P has a certain number of integer values. And it's m squared plus 2m minus 1, which I made the connection is just 2 less than the square of m plus 1. Now, I don't think that's a coincidence. I think we're going to have to do m plus 1 squared somewhere. But how can we sort of constrain P? Because right now, I mean, I've just got m's, n's, mr's, nr's. In theory, if I make everything big enough, I can get as many integer values for P as I want. Well, there's only so many ways to make a triangle. Right? Yeah, we're gonna have to have the triangle inequality. So if I bring back this triangle, I'll add the angle bisector in, but right now I think its only use is getting me this MR and this NR. Now, I definitely know that since n is greater than m, nr is greater than mr. So this one looks like it's going to be the longest side. In fact, r has to be greater than 1, otherwise the sides are too small. Because if r were less than 1, then they wouldn't be able to reach each other. So it has to be greater than greater than 1. If it was equal to 1, and then you just have a flat line. So r has to be greater than 1. So that's a nice observation. That restrains r, which sort of restrains p. Of course, there's n and m to figure out as well. What can we say here? NR is definitely greater than MR. Now, we could use the triangle inequality to say some things. So, for example, MR plus NR has to be greater than M plus N, but, I mean, that just shows me N has to be greater than 1, and I already said that. But NR has to be, so in a triangle, just so in case you're not familiar with the triangle inequality, and pick one side, it has to be less than the sum of the other two sides. So now NR, which I know is greater than MR, has to be less than MR plus M plus N. And I guess I could bring the N over, or the MR over to the other side, take out a factor of R. So that's definitely true. And M plus N is K times N minus M. So R has to be less than K, just dividing through on both sides. So R has to sit between 1 and K. Can we make anything stronger? Well, so we've done that side has to be less than the other two. This side has to be less than the other two. MR less than NR plus M plus N is already known because MR is less than NR, so that doesn't really tell us anything. So this sort of limits what R can be, which in turn, given that M and N are sort of fixed, tells me something about P? So P has to be between, P is M plus N times R times R plus 1. r has to be between 1 and k. So r plus 1 is between 2 and k plus 1. Right? Yeah. Oops. And then, so 2m plus n has to be less than p. Just multiplying everything by m plus 1, or m plus n, and then we get k plus 1 times m plus n on both sides. And so this is an integer, this is an integer, and so this should limit the integer values of p. And we know how many there are. So if I pick two numbers, like 2 and 17, how do I calculate the number of numbers in between them? Well, there's 3 all the way up to 16. So take 17 minus 2, which would be 15, and then subtract 1 for all the numbers in between, because I know this is 16 minus 3 plus 1 to be completely inclusive, which would be 14. So the number of values for p is, well, I'll leave it the way they did it. That's the number of values for p, but I can also see it's this number minus 1, because these are strict inequalities, because r had strict inequalities. Right? Yeah. So that'll be k plus 1 times m plus n minus 2m plus n minus 1. Now if I add 1 to both sides, I can get m squared plus 2m is k plus 1 minus 2, so k minus 1 times m plus n. Does this do anything for me? Well, I've got 2m, and we did have a way to write 2m earlier. I suppose I could also write this as k minus 1, because we've seen k minus 1 before as well. M plus n was n minus m times k. I'm pretty sure that's how we defined it. Yeah. And then we saw if you just take the k minus 1 and the m minus 1, or n minus m, you get 2m. So if instead I group these, I'll get 2m times k. And I've got a factor of m on both sides, so m plus 2 is 2 times k. So now I know what k is in terms of m. Right? So now we should get m plus n is equal to k m, or n minus m, which is equal to m plus 2 over 2 times n minus m. So 2m plus 2n is equal to m plus 2. I feel like I've lost sort of some direction here. Mn here minus m squared here plus 2n minus 2m. I can definitely get rid of the two n's on both sides. I can say 4m minus, well, let's bring the m squared over here. M squared is, take out the factor of m here, n minus 4. Divide by m on both sides, m must be n minus 4. Right? M must be n minus 4, so now can we... Oh, so then, I'll bring it over to the other side. N minus M must be 4. Right? Is that one of the possibilities? I feel like it is. N minus M must be 4, so we'll say the answer is A. Right? Minus, plus. Yeah, everything looks good. So, turns out we managed to solve it. Fantastic. So, there we go, and that wraps up our 2019 Fermat paper. Nice little question 25. I felt a little adrift there. Like, I liked the geometry at the start with the angle bisector. I thought that led into things nicely. Using the triangle inequality to set up those constraints on P was kind of interesting. But then I was just throwing stuff at the wall, manipulating the equation, and you never really want to be doing that. You know, with question 25, with like 3 minutes to go, you still want to have a plan. And so there might be a more elegant way to see that this is the approach, or there might be a better way to get n minus m. But overall, I'd say it's pretty good. Pretty good. Okay, so that's it for me. If you're looking for more grade 11 level content, I can always recommend the Hypatia papers. If you're looking for more Fermats, feel free to browse my channel. I've done tons of Fermats at this point. But that's it for me. I hope you have a wonderful day. Feel free to like or subscribe or anything like that, and I'll see you for more math in another video.